Today we're talking about the volume of cylinders and prisms. This is Unit 6, Day 1. So let's get into it. Our learning target of today is I can use my thinking ATL skill to transfer my knowledge of finding area of two-dimensional shapes to explore finding the volume of three-dimensional shapes. So what does all of that mean? Well, in Unit 5, we talked a lot about area, and we said it's the space that occupies a two-dimensional figure. So a rectangle, a parallelogram, a triangle. Now we're going to explore the space that occupies a three-dimensional figure. We call that volume. So what happens when we take a two-dimensional figure and give it height? We make it three-dimensional. One shape we'll look at is a cylinder. So a cylinder we should be familiar with. It's a solid object that has two circular flat bases that are parallel. So the bases are like the top and bottom. Imagine it's like a soup can and you have the top and the bottom of it. They're connected by a curved face that looks like a tube. And to find the volume of a cylinder, we use the following formula. Now, you don't have to memorize these formulas. You're going to find them all on your formula sheet. So let's go ahead and use that formula sheet to find the volume. First thing we always need to do whenever we're doing a problem like this is to identify what formula we actually have to use. So if we're finding the volume of a cylinder, let's check out that formula sheet, find the cylinder, there it is. And which of those is the volume formula? That one. So that's the one we're going to use. Volume is pi r squared h. So let's go ahead and write down our formula. So please write this on your notes as I write it on the screen. So we said volume is pi r squared h. So r squared is the radius of the circle base, and h is the height. So it's the distance between the two bases. Now in this case, the height is vertical, but sometimes you'll see cylinders kind of like flipped over on its side. Height can look horizontal. We'll see something like that. So let's plug in what we know. To find volume, we're going to replace pi with 3.14 so that we don't get a bunch of crazy decimals. Our radius is given to us as 12. And then the height in this example is 18. Now we're definitely going to want to use our calculator. So go ahead and plug this into your calculator and see what you get. You might want to pause and then come back when you have an answer. All right, so we got a pretty large number. Hopefully you got the same thing. And that is our volume. And you'll notice something a little different. What's different about how we write this unit? It's not just inches, but it's inches cubed. So remember, we're talking about three-dimensional figures that have length, width, and height. Notice we have radius squared times h. That means we're multiplying three attributes. That's why it's three-dimensional. So we're always going to write it as inches cubed. All right, next one. We have a cylinder. Use our formula sheet to identify the volume. Or identify the formula. So our volume is pi r squared h. Let's look at our figure. Did they give us our radius? Is that 8 radius? No, they actually gave us the diameter of 8. But remember, the radius is just half of a diameter. So what would the radius be if our diameter is 8? Our radius would be 4. So let's plug it in. We use 3.14, a radius of 4, and a height of 15 kilometers. All right, plug that into your calculator and see what you get. So our volume is 753.6 kilometers cubed. You could also see it written as cubic kilometers. That's another way that it might be written instead of kilometers cubed. So this is an example of a cylinder kind of knocked over on its side. So when we look at this, the radius is always a part of the circle. So they do give us the radius of 4, but notice the height of 12, it's horizontal because it's the distance between the two circular bases, which in this case happen to be on the left and the right. So just don't be alarmed by that. Height is not always vertical. So let's go forward with this one. We have a formula sheet. Identify the formula. Pi r squared h. And you know the deal. Replace what we need to. 3.14 for pi. Our radius is 4.
All right, guys, 5 minutes. 5 minutes before lunch.
Radius is 4, so we have 4 squared. And our height is 12. Okay, plug it into your calculator and see what you get. 602.88 feet squared. I don't think that 12 is supposed to be there. Feet cubed, sorry. Or we could say cubic feet. Okay, so those are some examples of finding the volume of a cylinder. The next thing we'll talk about are prisms. So a prism is a 3D figure that has 2 polygon bases. So polygons mean they're just shapes. So they could be triangles, they could be squares, they could be rectangles that are parallel and congruent, as well as lateral faces that are parallelograms. So a lot of that, it sounds like a lot, but you're going to recognize prisms. Most prisms use this formula where to find the volume, you find the area of the base and then multiply it by height, which is what we just did with a cylinder. We found the area of the circle and then we multiplied it by the height. That's a terrible drawing, but that's just showing kind of what we did. So let's take a look at some other prisms that are not cylinders. So we might see a rectangular prism. So this is when we start with a rectangle with a length and a width. We're used to finding the area of a rectangle of length times width. Notice we're going to see that there, length times width. And it has a height, so we give it that height. A cube is a square with a height that's the same side length of the square. So on your formula sheet, you have the rectangular prism. You don't have a cube, but you're really just going to use the rectangular prism formula for everything. Okay, so let's look at some examples of that. So let's find the volume. Right here we have a rectangular prism. So let's look at our formula sheet and find a rectangular prism. There it is. All right, what's our volume formula? We're looking for V equals length times width times height. Okay, formula, volume is length times width times height. I love rectangular prisms. I think this formula is the most simple formula. We have length, we have width, and we have height. It doesn't matter which one you assign as length, width, or height. It just makes sure that none of these are like parallel lines. Length and width are perpendicular, width and height are perpendicular. So let's plug in what we've got. Our volume, let's say length is 6, a width of 3, and a height of 7. So check that in your calculator and see what you get. I got 126 feet cubed, or 126 cubic feet. Pretty straightforward. Let's try another one. So we have another rectangular prism using our formula sheet. Now remember, the formula sheet only has rectangular prisms. It doesn't have a cube, and that's totally fine. A cube is a rectangular prism. Just like a square is a rectangle, it's just a special type. We're still going to use length times width times height. So look at these attributes. We have a length of 5, a width of 5, and a height of 5. Pretty straightforward. Let's plug them in. 5 times 5 times 5. Notice what's happening here. 5 times 5 times 5. Isn't that just 5 cubed? All right, let's see what we get. So you're going to notice these are showing up over what we wrote. I'm going to actually erase this, because if you realize that a cube is just the side cubed, that's why we call it cubed, or to the third power, you'll see that we have 125 centimeters cubed. All right, so from here, make sure you just follow the directions posted in the lesson and show what you know.